Let's now take a look at the energy stored in an elastic spring. K is the spring constant, F is the force that's needed to extend the spring, and X is the extension. So in this case, the work done is equal to half Fx because it is the area under the graph, and that will give you as a half Kx squared because your F can be replaced with Kx. So with that, the extension of the spring is F divided by K, and the energy stored is half F squared divided by K. Assuming that the same force is now being applied to a pair of identical spring with the same spring constant K, since the springs are identical, the force F that's applied on both springs will be shared equally by both springs. So in this case, your Fp acting on single spring will be half F, and K will still be the same spring constant. Xp is now the extension for the spring in parallel. So therefore, Xp is half F divided by K. In terms of elastic potential energy stored per spring, it will be half Fp Xp, and mathematically you will end up with half multiplied by 1/4 of F squared divided by K. So that's the energy stored per spring. Certainly, if you want to calculate the total energy stored, then you actually have to multiply by 2. Okay. The last case now will be if the same force F is now applied on two springs, two identical springs, which are actually paired in series. So in this case, you will find that each of the spring is actually subjected to the same force F. So in this case, for a single spring, the force exerted on the spring is F equal to Kxs. Xs is the extension of a single spring connected in series. So Xs is F divided by K. And clearly, in terms of the extension, you will find that the extension for each spring is double of that of the spring if connected in parallel. And the extension is equal to the case when force F is applied on the single spring. Let's now take a look at the elastic potential energy stored per spring. In this case, will be half F squared divided by K. You will see that in terms of the energy stored per spring, it is 4 times more than the energy stored per spring when the springs are connected in parallel, and the energy stored in the spring is the same as the energy stored if the force is applied to a single spring.